In this video, we are going to talk about the quotient rule, meaning that we want to figure out what is the derivative of a function f of x divided by g of x. Now, in the last video, we came up with the product rule, so just as a reminder of what the product rule said. It said that if we take the derivative of f of x times g of x, we get f prime of x times g of x plus f of x times g prime of x. And we had to do this, find this by doing an area computation. And so for the quotient rule, we expect that something similar is going to happen, that it's not just going to be the derivative of f divided by the derivative of g. And so what we're going to do is we're going to look at the derivative using rates of change, kind of like we did previously. So we're going to let u be equal to f of x, and v is going to be equal to g of x. Then if x changes by some amount delta x, we have the change in u. Delta u is going to be f of x plus delta x minus f of x. And delta v equals g of x plus delta x minus g of x. And as I mentioned before, this is the new value minus the old value. Okay, and so what we are interested in is we want to find the derivative of u divided by v, or f of x divided by g of x. And so we're going to look at, going to be delta u divided by v. And so this is going to be our new value, which is going to be u plus delta u divided by v plus delta v. Then we're going to subtract off u minus v. So just like before, this is our new value for u divided by v minus our old value. Well, let's combine these by getting a common denominator. So cross multiplying, we're going to have v times u plus delta u all over v plus delta v times v. And then minus, we're going to have u times v plus delta v divided by v plus delta v times v. So this is just getting a common denominator. Then combining things, what we have here is we're going to have uv plus v delta u minus uv minus u delta v, all divided by v times v plus delta v. And notice that we have a uv here and a minus uv here, so those cancel. And we're left with v delta u minus u delta v, all divided by v times v plus delta v. But what we're interested in is the rate of change of u divided by v, meaning that we need to divide by delta x, as that's the value that's changing. So we want delta u divided by v divided by delta x. So we're just going to divide by delta x. Now, to divide by delta x, it's the same as multiplying by 1 over delta x. So this equals v delta u minus u delta v divided by delta x v times v plus delta v. But to make this easier to compute, what we're going to do is we're going to multiply the top and the bottom of this expression by 1 over delta x. Since we're doing the same thing to the top and the bottom, nothing changes in the value, but this will be v delta u over delta v minus u delta v over delta x divided by just v times v plus delta v. And the reason why we like this is that we know how to deal with these delta u over delta x and delta v over delta x. Those are just derivatives. And so, like we did in the last video, we're going to take the limit as delta x goes to 0 of both sides. So taking the limit as delta x goes to 0 of the right-hand side, we have the limit as delta x goes to 0 of v delta u over delta x minus u delta v over delta x, all divided by v times v plus delta v. Now, on the left-hand side, we get the derivative that we want. We get the derivative of u over v. And on the right-hand side, we're going to break this limit up using limit rules. So we'll have v times the limit as delta x goes to 0 of delta u over delta x minus u, the limit as delta x goes to 0 of delta v divided by delta x. I wrote a d there, but that's delta x. Then we divide this by the limit as delta x goes to 0 of v times v plus delta v. So now taking these limits, doing something very similar to the product rule, we're going to have v times, as delta x goes to 0, delta u over delta v goes to the derivative of u divided by the derivative of u with respect to x. And we have minus u, the derivative of v with respect to x. And on the bottom, v is a constant, so it doesn't change, and delta v goes to 0, so we're just going to be left with v squared on the bottom. And so this gives us a formula for the derivative of u divided by v. So let's write that formula in terms of f and g now. And so this is our quotient rule. And so what we found is if f and g are differentiable, then the derivative of f of x divided by g of x is going to be equal to v, which was g of x. So we have g of x times the derivative of f, which was f prime of x, minus f of x times g prime of x, because delta v dv over dx is g prime, all divided by g squared, but v squared, which is g of x squared. And so this is our quotient rule. So now the quotient rule says that the derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. And so that is kind of complicated to remember. One thing that can help, though, is that the numerator looks a lot like the product rule. So the product rule was the derivative of f of x times g of x is equal to f prime of x times g of x minus f of x times g plus f of x times g prime of x. And so notice the only difference here is that we changed the plus to a minus. And so if you write the product rule in this order, then the quotient rule is the same thing. You just change the plus to a minus and divide by g of x squared, by the bottom squared. So let's look at some examples now. And so we're going to let y equal x squared minus 2x plus 1 divided by x cubed plus 3. And we want to find dy over dx. So we want the derivative of this expression. So the derivative of y is going to be what we just found. So we're going to have the derivative of the top, which is the derivative of x squared minus 2x plus 1, times the bottom, which is x cubed plus 3, minus the top, which is x squared minus 2x plus 1, times the derivative of the bottom. And we're going to take that whole thing divided by the bottom squared. And so now, taking these derivatives, we're going to have the derivative of x squared is 2x, the derivative of 2x is 2, then the 1 goes away, times x cubed plus 3 minus x squared minus 2x plus 1, times the derivative of x cubed plus 3, which is going to just be 3x squared, using the power rule. And so now let's multiply all divided by x cubed plus 3 squared. So now let's multiply out our expressions. So we're going to get 2x to the 4th minus 2x cubed plus 6x minus 6 minus 3x to the 4th minus 6x cubed plus 3x squared, all divided by x cubed plus 3 squared. And so combining things, we get negative x to the 4th plus 4x cubed minus 3x squared plus 6x minus 6, all divided by x cubed plus 3, all squared. And so that then is our derivative. And so we've computed the derivative of this function x squared minus 2x plus 1 over x cubed plus 3. So now let's look at another example. And so here we want to find the line tangent to the curve y equals e to the x divided by 1 plus x squared at the point 1, 1/2 e. Okay, so we want the tangent line. And so remember, to find the tangent line, we first need to find the slope of the equation of the curve at that point. So we want to know what the slope is at 1, which is going to just be the derivative evaluated at 1. So we want dy over dx. So we're going to do the same thing as before. So we take the derivative of the top, which is the derivative of e to the x, times the bottom, which is 1 plus x squared, minus the top, which is e to the x, times the derivative of the bottom, all divided by the bottom squared. Okay, so let's compute these derivatives. So the derivative of e to the x is e to the x. So we have e to the x times 1 plus x squared, minus e to the x times the derivative of 1 plus x squared, which is just 2x, divided by 1 plus x squared, all squared. And now we can rewrite this, just pulling the e to the x out of everything. We have e to the x times 1 minus 2x plus x squared, divided by 1 plus x squared, all squared. And so this then is our derivative from the quotient rule. And so now what we want to do is we want the slope at the point 1, 1/2 e. So we're going to plug 1 in. So we're going to look at what is this when x equals 1. This will be e times 1 minus 2 times 1 plus 1 squared, all divided by 1 plus 1 squared squared. And so this becomes e times 1 minus 2 plus 1 divided by 4, which, if you actually check in the numerator, you get 0. 1 minus 2 plus 1 is 0. So what we found is we have a slope of 0. So in other words, it is horizontal there. So if you actually look at the graph at the point 1, 1/2 e, the graph is horizontal there. And so we're going to say that this is where the point is. And so the graph is doing something where it becomes flat at that point. I'm just drawing a random graph. This is not the actual graph. But at this point of 1, the tangent line has a slope of 0. And so using our point slope formula, we have y minus 1/2 e equals m, which is 0 times x minus 1. So y equals 1/2 e. So kind of a boring tangent line for all that work. It was just a horizontal line with a value of 1/2 e. So now we're going to look at one more example. So here we want to find the following. So f of x is going to be equal to 3x x cubed plus 2x to the minus 1/2 divided by x. We want to find f prime of x. Now, there is an easier way to do this than with the quotient rule. And so notice f of x, if we just actually compute the division, is going to be 3x squared plus 2x to the minus 3 halves. And we can compute that derivative using the power rule a lot easier than if we would use the quotient rule. And so we're going to use the quotient rule just for practice, but just be aware, you should check to see if you can do it an easier way than just going straight to the quotient rule. But let's use the quotient rule for practice. So the derivative of f under the quotient rule is going to be the derivative of the top times the bottom, which is x, minus the top, which is 3x cubed plus 2x to the minus 1/2, times the derivative of the bottom, so the derivative of x, all divided by the bottom squared, which is just going to be x squared. So computing this derivative, we're going to have 9x squared minus 2, plus 2 times minus 1/2 x to the minus 3 halves, just using the power rule, times x, minus 3x cubed plus 2x to the minus 1/2. And the derivative of x is just 1, all divided by x squared. So now if we simplify this, we're going to have 9x squared minus 2, or minus just x to the minus 3 halves, times x, minus 3x cubed minus 2x to the minus 1/2, all divided by x squared. Now multiplying our x through, we have 9x cubed minus x to the minus 1/2, minus 3x cubed minus 2x to the minus 1/2, all divided by x squared. Combining things, we get 6x cubed minus 3x to the minus 1/2, all divided by x squared. And then doing the division, we get 6x minus 3x to the minus 5 halves, which is what we would have gotten and we just used the power rule on this expression right here. And so the point of this is that there sometimes is an easier way than going straight to the quotient rule. But we could use the quotient rule, and we got this derivative.